A man runs from point A in a straight line across a track A, B, C, D, E, F, and G. And this is a velocity time graph, velocity time of the motion of the man. So he doesn't run up a hill and then flat and then down a hill. That's not what this graph is meaning. It's his velocity that increases, remains constant, and then decreases, while the man all the time is actually running on a straight, flat line in the positive direction. We can see that because everything's above the zero. So the questions here below, first of all, ask us to describe the motion, and then later we have to do some calculations. So let's start with the description. We need to describe the motion from A to B. So we can see his velocity starts at 0 meters per second when we start to observe him at time 0, and it increases steadily until at B the velocity is 2,5 meters per second. So this shows acceleration. It is uniform acceleration. That means that the gradient here is straight. It's not curving either that way or that way. We don't have a curve. It is a straight line, meaning that the rate of change of velocity is constant. How much the velocity increases per unit time is always the same. If we take equal amounts of time, if we were to break this up into equal times, then for each the increase of velocity is the same. That increase and that increase are the same. And if we carry on, that increase is the same as that increase, the same as that increase. Of course, I'm doing it roughly, so it might not look perfectly so, but if you were to do it perfectly, you would see that the increase per unit time is always the same. The increase of velocity, the change in velocity per unit time is constant, because acceleration is the rate of change of velocity. And so velocity changes at a uniform rate in uniform acceleration. So we are busy describing the motion. We have uniform acceleration from a velocity of 0 meters per second to a velocity of 2,5 meters per second. And that all takes 25 seconds. We could also say that there's a uniform positive acceleration from 0 meters per second to positive 2,5 meters per second. By us writing 2,5, we are implying positive anyway, so it's not really necessary to say that, but let's just speak about that. There's a uniform positive acceleration. The gradient of a VT graph tells us acceleration. We can see that the gradient is sloping upward. That's a negative gradient, that's a positive gradient, and that's the case in this graph. The gradient is sloping upward. That means that we have a positive gradient, and the gradient of a VT graph means acceleration. And so that tells us, okay, there's a positive acceleration. Now we need to describe the motion from B to D. So there's B, and we're taking it till there, D. So we can see that now the graph is flat. What does that mean? The velocity is uniform. So we have uniform velocity. We could always say uniform positive velocity, because there's the zero line, and of course this is above the zero, so it's positive. Down here would be negative. So uniform positive velocity. What does a positive velocity mean? It means that the man is moving in the positive direction. If we take the positive direction to be right, so we say let positive direction be right, then a positive velocity means that he's moving towards the right all the time. So there's a uniform positive velocity. The magnitude of that velocity is 2,5 meters per second, and the duration of this interval is from time equals 25 seconds to time 50 seconds. So delta t is final time 50 minus initial time 25. And so that is 25 seconds for 25 seconds. If we like, we can also add he's not accelerating. Of course, by saying he's moving at uniform velocity, we mean he's not accelerating, so it's not really necessary. Now we're asked, without using equations of motion, so just using the graph, we must calculate the acceleration of the man between E and G. So this is a velocity time graph, and the gradient of a velocity time graph gives us acceleration. Why? Because the gradient is rise over run, and rise here is change in velocity, and run is period of time, delta t. So we need to get the gradient from E to G. So there's E and there's G. So we can immediately see this is a negative gradient. Remember, positive gradient slopes up and negative gradient slopes down. And why that's so, we'll also see as we do the calculation. So let's write this in full. That's V final minus V initial. In other words, this point is V final, and this point here is V initial. So we need V final minus V initial, and that's divided by T final minus T initial. Again, T final we've indicated in a rectangle and T initial in a circle. So let's get our information. V final, along there we see it's 0 meters per second, and V initial we see is 2,5. Both of them are meters per second. T final we see here is 100, and T initial we see here is 60, and that's seconds. So we have 0 minus 2,5. Be careful, it's not equal to 2,5. It's equal to minus 2,5 meters per second. Divide by 100 minus 60 is 40 seconds. So our answer is minus 0,0625. The unit is meters per second per second. Meters per second squared. Now, this negative tells us direction because acceleration is a vector. So a vector quantity has both magnitude. Now we've seen the magnitude is 0,0625, and it also has direction, and the direction here is given by negative. But what does a negative direction for acceleration mean? It means that it's speeding up in the opposite direction of motion. So we give our answer like that, 0,0625 meters per second squared is the magnitude of the acceleration, and then the direction is in opposite direction to motion. Now we have to calculate the distance covered by the man in 100 seconds. Distance is a scalar, so we're not going to have to give any direction here. Its equivalent vector is displacement. Now the area underneath a VT graph gives us displacement, or it gives us the magnitude of displacement, which is the same thing as distance if the motion is linear, as is the case here. So we need to get the area underneath the graph for all 100 seconds. So it's the entire area all the way here. So how do we get the area? We break it up into this triangle, and its area is going to be half base times height, where the base we could take as 25 and the height as 2,5. And then we're going to add this rectangle over here, and it's a rectangle, so its area is length times breadth, and here we're going to use 60 minus 25, which is 35 seconds, as our length, and then again 2,5 minus 0, in other words 2,5 meters per second as our breadth. Then we also have this triangle here, and it has area half base times height, and the base there is 100 minus 60, which is 40. So let's write our entire equation. Half base times height for the first triangle plus length times breadth for the middle rectangle plus half base times height for the last triangle. So let's substitute. We've got half. Well, it really doesn't matter which one we write first. Let's write 2,5 meters per second times height, which is 25 seconds. We can see the seconds cancel, so that ends up with meters, plus length times breadth for the middle rectangle. So we've got 2,5 meters per second, and that's multiplied by this 35 seconds. The seconds cancel. Again, we have a unit in meters there. And now we have half 2,5 meters per second multiplied by 40 seconds. Again, the seconds cancel. We've got meters. So what does that give us? Half 2,5 multiplied by 25 is 31,25. The unit is meters. Plus 2,5 times 35 is 87,5, again meters, plus half. Don't forget the half when you do the calculation. It's easy to forget it. Half 2,5, so you could write on your calculator 2,5 times 40 divide by 2, and that gives you 50, and again it's meters. Add these all up and you get 168,75 meters. So that's the distance. Notice distance is a scalar, so we only have to give the magnitude. And in the case of linear motion, straight line motion, distance has the same answer as just the magnitude of displacement.
And before we go, have you already liked? Have you subscribed? Have you left me a comment? And please go and visit my website. You'll find a lot of resources there, and they're categorized in a way that will make it very easy for you to find what you need. Until we meet again, learn science!